Stars are fundamental building blocks of galaxies, responsible for the manufacture and distribution of heavy elements such as carbon, nitrogen, and oxygen. Their characteristics are closely tied to planetary systems.
Star formation. Stars are born within clouds of dust and scattered throughout galaxies, which can collapse and form protostars. Three-dimensional computer models predict that the spinning clouds of collapsing gas and dust may break up into 2 or 3 blobs, which explains why the majority of stars in the Milky Way are paired or in groups of multiple stars. As the cloud collapses, a dense, hot core forms and begins gathering dust and gas. Not all of this material ends up as part of a star. The remaining dust can become planets, asteroids, or comets, or may remain as dust.
A star the size of our Sun requires about 50 million years to mature from the beginning of the collapse to adulthood. Our Sun will stay in this mature phase, on the main sequence as shown in the Hertzsprung-Russell diagram, for approximately 10 billion years.
Stars and their fates. In general, the larger a star, the shorter its life, although all but the most massive stars live for billions of years. When a star has fused all the hydrogen in its core, nuclear reactions cease. Deprived of the energy production needed to support it, the core begins to collapse into itself and becomes much hotter.
If the star is sufficiently massive, the collapsing core may become hot enough to support more exotic nuclear reactions that consume helium and produce a variety of heavier elements up to iron. However, such reactions offer only a temporary reprieve.
Gradually, the star's internal nuclear fires become increasingly unstable, sometimes burning furiously, other times dying down. These variations cause the star to pulsate and throw off its outer layers, enshrouding itself in a cocoon of gas and dust. What happens next depends on the size of the core.
Which process happens inside a star?
Nuclear fusion reactions power the Sun and other stars. In a fusion reaction, 2 light nuclei merge to form a single heavier nucleus. The process releases energy because the total mass of the resulting single nucleus is less than the mass of the 2 original nuclei.
When the Earth's sun would die, it would change into a
red giant is a dying star in the final stages of stellar evolution. In about 5 billion years, our own Sun will turn into a red giant, expand and engulf the inner planets, possibly even Earth.
When the hydrogen fuel ends up in a star, it
eventually the core of the star runs out of hydrogen. When that happens, the star can no longer hold up against gravity. Its inner layers start to collapse, which squishes the core, increasing the pressure and temperature in the core of the star.
When the hydrogen fuel ends up in a star, it
What happens to a star when it starts to run out of hydrogen? After hydrogen fusion, low-mass stars begin to fuse helium into carbon.
Black holes are.
A black hole is a place in space where gravity pulls so much that even light cannot get out. The gravity is so strong because matter has been squeezed into a tiny space. This can happen when a star is dying. Because no light can get out, people can't see black holes.
Which mathematical quantity is imagined to be present at the center of a black hole?
At the center of a black hole, as described by general relativity, may lie a gravitational singularity, a region where the spacetime curvature becomes infinite.
In every nebula, a star is beginning to form.
Some nebulae, more than one nebula, come from the gas and dust thrown out by the explosion of a dying star, such as a supernova. Other nebulae are regions where new stars are beginning to form. So answer is false.
The nebula formed when a dying sun-sized star begins to shed its outer layer is called as.
When a star like our Sun dies, it doesn't explode into a supernova or collapse into a black hole. Instead, it gently sheds its outer layers, which form a beautiful cloud called a planetary nebula.